Okay, so yeah, we'll begin with our test summary today, and then probably after recess or maybe immediately after this, we're going to have a look at, we have an exam question in our notes book that we haven't gone through, that we will go through, because it's a good indication of integration skills for the exam. So just our summary here, this is the protocols at this stage. So Tuesday, the 10th of June, so it's not the coming Tuesday, it'll be the following Tuesday, keeping in mind we do only have one lesson next week together. The test will go for 60 minutes at this stage, okay? And at this stage it is 50 marks. You get your calculator, and as far as I'm aware, we're still in the negotiation process, but we're going to give you the formula sheet. You'll see it at the end of 2024 test. So it's the same one that's on the back of your calculus notebooks. And the reason we're going to give that to you is because you're required to do some differentiation as well. There it is.
22.
On the back of the 2022 test. Okay, so because you're required to do some differentiation, we'll give you that. So that means you can still bring along your unit circle if you want, there's one there. You can still bring along the SACE approved formula sheet, and you still have your cheat sheet to use and to produce as well. Okay, so we'll make sure that we include that one with the test. Okay, so that's you can make your cheat sheet, and we've got the approved formula sheet. That's permitted. Okay, so as far as the content goes, it's just chapter 4. So we're going to have 4A, and then we have 4C, D, E, F. So 4C, D, E, F, they're rules of integration, and then in 4A we have the area approximations using lower and upper rectangles. So you will be required to do a lower and upper rectangle estimate. It's not going to be anything like 100 rectangles. I think the most we've asked in a test in the past is 5 rectangles. Sorry?
4G. Are we doing that?
4G? Yes, 4G is on there as well. Why didn't that print?
Okay.
Thanks, Sammy. So 4G is also included, which is definite integrals. Maybe I've wrapped it up with 4C. A good pickup. 4G is definitely included. Okay, as far as the skills checklist goes, I think this is a really simple way to break it down, right? So firstly, we have determine area approximation using lower and upper rectangles. I was just saying the most rectangles that we've had in the past is 5. Then we've got evaluate indefinite integral functions.
Does that mean you have more than 5 then? We can have more than 5 rectangles, or the max is 5?
The max is 5. Yep. The max we would give you is 5. It just gets a bit tedious adding more rectangles. It doesn't add any depth to the question. Okay, so skills there. So integrating these functions, evaluate definite integrals, showing all steps in the fundamental theorem of calculus, determine area under the curve, make and manipulate integral statements from differentiation. So this is where you're required to differentiate. Here's a function, differentiate it, hence integrate it. And then we've got proving those properties of definite integrals that we were looking at in question 5 of exercise 4C yesterday. Here's our revision resources. We have tests from 2017 through 2024, so there's another update you can add to your sheet if you like. We've got the review sets, and there is some more if you run out of all that stuff there. Got a number of questions on the back here. Would we like to work through it together, or do we want to? Yep, cool. Okay, so we'll work through this together, and Amy, you can just shut that door. Ambient noise today, don't we? Just echoing throughout the building. Okay, so let's do this comprehensive review together. This is quite a short one, so it won't take very long at all. And it's good that we are doing it together because we're going to draw out some of the skills that you might have seen present in towards the end of G. That'll come out in question 4 here today. Okay, so firstly we just have to evaluate this indefinite integral. We have 3x, take away sine x, plus e to the 2x with regards to x. And this is a good one for us to evaluate straight away because we're just incorporating a number of different terms. So 3x, all right, it's just 3 times x. It's going to go to 3x squared on top of 2. The integral of sine x is negative cos x. So we'll have negative cos x, which will be positive cos x. And the integral of e to the 2x, or e to the kx, is going to be 1 on k. E to the kx. And then plus c. Okay, don't forget, anytime we have an indefinite integral, that means there's no boundary, we always chuck that plus c on. Okay, so that's our answer to question 1. Then we have question 2. Evaluate the integral from 2 to 5 of 1 on top of 3x plus 1. Okay, so this is one of those ln ones. Alright, so we have the rule for this. This was recently added to the course in 2022 or 2021. So if we have 1 on ax plus b, then the integral of 1 on ax plus b is ln of ax plus b, 1 on a ln of ax plus b, provided ax plus b is positive. Now it should say that in the question, it should say stipulate that integrate this function given ax plus b is positive, because we can only integrate it given that it is positive. So if we're going to apply that to this one here, it's a definite integral, so we're going to apply the fundamental theorem of calculus. And 1 on 3x plus 1 is going to go to 1 on 3 ln of 3x plus 1. Now, you might see in solutions, or you might see if you're doing spec, for example, that rather than brackets, they would put modulus here. We'll accept either, both are correct, given the definition. So modulus 3x plus 1 just makes it positive. All right, so just so you're aware, if you see that notation pop up in the solutions. Integrating from 2 to 5. Okay, so that's our first step. All we've done is integrate it and state the boundaries. Then we'll put in the upper boundary, so ln of, and we have 3 times 5 plus 1. And then we have to take away a third ln of 3 times 2 plus 1. So this gives us a third ln of 16. And this is a third ln of 7. A third is common, so we'll factorise it. I'll do this over 2 steps just to draw out those log laws. ln of 16, take ln of 7. ln of a, take ln of b is ln of a on b. So we have a third ln of 16 on 7. So you may have developed, you may have seen that skill yesterday. So we did 1 on ax plus b on Tuesday, and then we did definite integrals yesterday, so we're combining both of those skills. Okay, let's move on to question 3. However, I need a whiteboard eraser, tissues, fresh ones. Okay, so this is a good kind of problem solving question that involves a bit of algebra. For 3, we have find a given the integral from 0 to a of 3e to the 2x take 1 with regards to x equals 3e to the power of 4. So we have a good problem solving one here as well. Lots of algebra involved. Should be fun. So the first thing that we're going to do is we're just going to integrate it. All right, we'll integrate it. We can even factorize the 3, right? So we can express it like this. Okay, so we have that statement as true. And we can even divide both sides by 3 to get rid of it, because that's going to divide quite nicely here, isn't it? We have the integral from 0 to a of e to the 2x take 1 equals e to the 4. Don't forget your dx is like that. Okay, so then all we're going to do is process this side. We're solving it for x, right? Or we're solving it for a, it's going to be. So the integral of e to the 2x take 1 is going to be half e to the 2x take away 1. And we're integrating from 0 to a. And we'll just keep the e to the 4 over here. What's this going to simplify to? It'll be half e to the 2a take 1, take half e to the 2 times 0, take 1, equals e to the 4. Alright, so we've just sucked in our lower and upper boundary. Let's process this a little bit. I think half is common here, right? So if we want to get rid of the half, just to simplify the problem a bit, we can factorize it and divide it. I think a good way to think of it is just to multiply both sides by 2, right? If I multiply both sides by 2, I'm going to get rid of the half of both of these terms. So we'll have e to the 2a take 1, take away e to the minus 1 equals 2e to the 4. Okay, now we're solving for A. That's what the question wants us to solve for, right? We're trying to get A by itself. So first we're going to move this term over to the other side. So I'll come up here, we're going to have e to the 2a take 1 equals 2e to the 4 plus e to the minus 1. Okay, so you have, presumably, maybe they pop up a bit later in some of the exercises, but I don't think you've seen this kind of thing before. This is a skill that you've developed from doing the practice tests. So we certainly have this question, it's pretty common in the practice test. It's good application of definite integrals and the algebra processes. So let's just talk what we've done so far. We've equated them, we've performed the integral, we've subbed in the boundary, and now we're just trying to solve that equation for A. We're going to start by ln both sides, natural log of both sides. And I'm just going to whack that whole thing in brackets. They don't collect at all. We can't really simplify that because we can't split that logarithm. We just have to look the whole logarithm of that side. But the left-hand side does simplify to 2a take away 1. And so what we'll do is we'll add 1 to both sides and then divide by 2. Alright, so that's the exact value of A that satisfies this statement. Now we can actually solve A using our calculator as well. That is an equation that you can type into your calculator in Solven or in Equation Solver, and it will give you a value for that answer. So there is a way to check your answer using your calculator. Remember, your calculator is your guide. Alright, any questions about 3 there? Cool, so let's look at 4 then, and I'm glad we're going through this together, because I frequently have questions about 4. Did anyone finish G yesterday? Yeah, good. Alright, so you would have seen some of this pop up then. So what we have is we have given f of x is the integral from given the integral from 2 to 5 of f of x equals 6. Now this is what it's supposed to say. Integral from 2 to 5 of f of x with regards to dx equals 6. I reckon some of it hasn't printed. No, we'll be right. Okay, so the integral from 2 to 5 of f of x is 6, and we are asked in part A, find the integral from 2 to 5 of f of x on top of 3. Okay, so what we're going to do here is we're just going to apply properties of definite integrals to simplify it. So remember, anytime we're dividing by 3, we should always think about that as times a third. And if it's times a third, if it's a third, we can just bring it out the front, can't we? Okay, see that? And we know, we're told in the first part of the question that the integral from 2 to 5 of f of x, that this part here simplifies to 6. So we are left with a third times 6, which is 2. Okay? Alright, in the next one we are asked, how about the integral from 5 to 2 of f of x? Okay, so this is going to be a direct application of one of the properties of definite integrals. It's this property here, the integral from a to b of f of x is equal to the negative integral from b to a of f of x. Okay, so what that means is if we switch the boundaries, it makes the value negative. Alright, so the integral from 5 to 2 of f of x is going to be negative 6. Alright, that's the only difference between this one and this one. This one is positive 6, so if we flip the boundaries, the integral will evaluate to negative 6. Okay, then on to C. Now C might look a bit confusing, but there's a simple trick to this. We have the integral from 2 to 5 of f of x plus x. F of x plus x. Now all we're going to do here is split the integral. We have the integral from 2 to 5 of f of x plus the integral from 2 to 5 of x. Now this here, we don't know what f of x is, but we know that this part evaluates to 6. And then this part here we can evaluate using the fundamental theorem of calculus or just our calculator. Remember, your calculator is your friend. The only time you're required to show you're working is if it says using the fundamental theorem of calculus. So if we're typing that in, we're going to have what, 5 squared on 2 take away 2 squared on 2. That's what it's going to work out to. So what's that? 12.5 take away 2, 10.5. So what do we got? 16.5. Alright, so we've split the integral. This part we can do, okay, because it's just we're integrating x. This part we need to recognise that that value is 6. We're told that in the question. So that's how you're going to do some of those questions in the later part of G. They're quite good. So yeah, so that's a pretty thorough review. Are there any questions from the review? Alright, I'll stop the video there.